What's up, everyone? We are going to be solving some multi-step inequalities. So far, we kind of rehashed what the heck is an inequality. Then we went and talked about what to do with addition and subtraction, and then multiplication and division. We looked at separately, right, because it's a teensy bit different. And the reason being, right, is because those negative numbers kind of work in the opposite direction that positive numbers do. And so we want to make sure that we account for that by flipping the symbol when we multiply or divide by a negative number. All right, so to solve multi-step inequalities, we're going to simplify each side of the inequality if necessary first. Then, as usual, when we are solving things, we are using our buddies, inverse operations. To isolate the variable, and we are going to flip, like I said, the inequality symbol whenever multiplying or dividing by a negative number. All right, so we're going to solve these guys and graph our solutions. So we always start by working from the outside in towards the variable. We have to go through that reverse order of operations, right? Get rid of any addition or subtraction before we can do the multiplication and division. So I'm going to add 3 to both sides here. Then we are going to have a negative 2x minus 4. And now we're going to divide both sides by negative 2. But because that is a negative, right, we're going to flip the sign. And so now we're going to have strictly greater than. So this will be x is greater than negative 2. And so when we graph this, we're going to find negative 2 right there. Open circle. And we want numbers to the right. Okay. Next, I'm going to subtract 2 from both sides. I'm going to have 3x is greater than or equal to 9. Divide both sides by 3 to get x all on its lonesome here, and we'll have x is greater than or equal to 3. I didn't have to do anything to rearrange the equation or the inequality symbol because I divide by a positive number. And so we're going to have a closed circle here at 3, and that, oops. You guys know my battle with scribble erase. All right, and then we're going to hang here to the right because we want values bigger. All right, so now we have variables on both sides. So notice we've got x's on both sides here. All right, so we need to get variables on one side, constants on the other. All right, so how I'm going to do that is I'm going to move this 3x. So I'm going to actually erase these underlines here, maybe. Nope. All right. Try it again. All right, so that's not confusing anyone. We're going to subtract 3x from both sides. So now I'll have 2x's minus 6 is greater than 4. Now I need to work on getting the constants. Now this is just straight a two-step inequality here. So I'll take care of that Adding a 6 to both sides. I'll get 2x is greater than 10. Divide both sides by 2. And we get x is greater than 5. Strictly greater than, and no flipping the sign business here. You're going to have open circle here at 5. We want values to the right. Okie dokie, we get to a couple of my favorites here. So we've got the distributive property making an appearance. All right, so first thing that I'm going to do, this kind of falls into where I said simplifying might have to happen before we do anything further. So I'm going to distribute 5 to both parts here. And I'll end up with 10x plus 5 is less than 4x plus 15. All right, now we got variables on both sides. So I'm going to start by removing 4x so that we'll end up with the variables on one side. So I had 10 x's, you took 4 from me, now I have 6 x's plus 5 is less than 15. Subtract 5 from both sides. Get 6 is less than, 6x is less than 10, and this lost my x there. See, if you're not new here, you know I was talking about the scribble erase. That's what I meant. Alright. Only works when I don't want it to. And now we've got x is less than 5 thirds. And with these not having a graph on, we're just focusing on the algebra here. All right. One more. I bet you can try this one out on your own. So go ahead, try this guy out here. Let me know what you think. All right, so hopefully you saw that and you're like, I'm going to distribute that. So you've got 12x minus 6 is less than or equal to 2x plus 4. Now we're going to take this 2x away from both sides. And we got 10 x's minus 6 is less than or equal to 4. Gonna get those constants on the same side. So we're gonna add 6 to both sides. We got 10x is less than or equal to 10. To both sides by 10. And we get the x is less than or equal to 1. Very nice. All right, flip it over. And we're going to talk about a word problem. Inequalities really lend themselves to word problems because often in life, right, there's a range of values that we could go for, not just the one right answer that we are used to seeing with equations. So Emily is saving money to buy a new laptop. She already has $150 saved. You go, Emily. Each week she earns $25 from her part-time job. The laptop is going to cost her $450, and she needs $50 more for accessories. So let's write and solve an inequality to determine how many weeks she needs to work to have enough money to buy the laptop. All right, first of all, she's only getting $500 a week. She needs a new job. Anyways, that's aside. Here we go. So let's let let x be equal to the number of weeks worked. All right, so let's see. Our friend M here, she's already got $150. And then on top of that, she's going to get 25 more dollars every week that she works. So we can model that with 25 times X. And so this is the amount that she's going to save. Okay. And so she could always save more, but she can't save less. Or equal to that 450 for the laptop itself, plus the $50 for the accessories, probably like a case or something. All right. So, what's going on here? We need to start combining some like terms. So, on the right hand side, we can combine that 450 and 50. Y'all might have already done that on your own when we wrote the inequality. That's 500. All right, so now I'm gonna take away this 150 here because she's already earned that, right? We don't have to worry about 150 of that amount. So this is gonna take us down to 350. And now this is where we're trying to find that if she's every week making $25, if I divide that amount by 25, I'll figure out how much or how many weeks she needs to work. And so that will be 14. All right, so of course we're going to answer with a nice sentence here using our therefore symbol. Emily needs to work 14 or more weeks to save up for the laptop. All right, last one. Ooh, we got distributing variables on both sides. They like terms to combine. Oh, these are good problems. So let's go ahead and see what's up here. First, I'm going to distribute this 4. So we're going to have 8x plus 12 minus 6. You know what I almost did there, guys? I almost didn't distribute the 4 to the 3. Caught myself just in the nick of time. All right, so you might find yourself, right, of me, math teacher, making mistakes like that. That means it can happen to anyone, right? So not a big deal, but something to watch out for. All right, so I've got 8x plus 6 because I did 12 minus 6. And that is greater than 3x plus 18. Again, trying to get this to be variables on one side. So I'm going to subtract 3x, got 5x plus 6 is greater than 18. All right, now I can take care of that 6. Subtract 6 from both sides. Get 5x is greater than 12. And we'll divide by 5. There you have it. That's going to be 12 fifths or 2.4. X is greater than 2.4. Okie dokie. So we've got distributing again. 15x minus 5 minus 4 greater than or equal to 4x plus 11. All right, so this is going to be 15x minus 9 is greater than or equal to 4x plus 11. All right, Again, I want to make this variables on one side. So we're going to end up with 11x minus 9 is greater than or equal to 11. Add 9 to both sides. Okay, 11x is greater than or equal to 20. Have to divide both sides by 11 to get x alone. And 20 divided by 11 is kind of gnarly. It's going to be about 1.82. So x is greater than or equal to 1.82. All right, guys, we did it. We solved some multi-step inequalities. Make sure you stop back and learn all about those compound inequalities next, and then we'll be all done. Bye.